Welcome to Physics, Newton's Laws of Motion, Session 5. The aim of this session is to calculate tension in case of pulley system. Also, we will see how to calculate acceleration in case of the pulley system. Here we are studying first thing, motion of two bodies connected by a string. We call with the pulley system a body. As we see in this figure, there is a very interesting figure here with two bodies I have shown. A blue color body, another is a red color body. Blue color body is heavy, so it starts sliding down. There is a pulley system attached here, fixed to the rigid support. It is called an Atwood machine. We will try to calculate the acceleration of the mass m1 and m2 when this pulley system is at rest. That means the rigid support is not moving. Now only mass m1 and mass m2 are in motion. Pulley system is at rest. So let us see how the two bodies are going to move. So as we see here, the pulley is only in rotation and blue color body is coming down, red color body is moving up. Let us analyze when the pulley is at rest, how the two bodies are going to move. Let us consider this is the rigid support, this is a pulley which is at rest. Only rotation is possible. Here we have attached one mass. This mass suppose I call m1, and here we have another mass. Let me call this mass as mass m2. Here m1 is greater than m2. So therefore this body is going to come down and this body is going to move up. Let us analyze the forces on m1. We make free body diagram for m1. Due to gravity, one force here is m1g, upward tension T. Since this string is same, throughout tension will be same. Inextinguishable massless string. Due to gravity, this will pull down m2g. The acceleration of mass m1 is downward as a. Similarly, acceleration of this mass m2 is also a, but it is in the upward direction. Now let us write free body diagram for the mass m1 and m2. Write the equation for mass m1 and m2. m1g, since body is moving down, minus t is equal to m1a. This is our equation 1. For the second body, t minus m2g is equal to m2a. This is equation number 2. Solving these two equations, adding, we get m1 minus m2g is equal to m1 plus m2 to a. So acceleration of the system will be m1 minus m2 by m1 plus m2 into g. Substituting this value of acceleration in any of the equation, we get tension T. Substituting value of acceleration, the tension T will be equal to 2 m1 m2 g divided by m1 plus m2. So we have seen in the case of Atwood machine, when one mass is heavier than another mass, this mass is going to be pulled down with an acceleration a. This mass is being moving up with an acceleration a. We made free body diagram. We drawn all the forces acting on the bodies and generated equation 1 and equation 2. With these two equations solving, we have got an acceleration m1 minus m2 by m1 plus m2g, and tension T is equal to m1 m2 by 2 m1 m2 by m1 plus m2 into g. Acceleration of both mass m1 m2 is same because the string is inextensible, flexible. So see here also in this case, this body is going to move down, and as well as this body is going to move up. We can again see how the two bodies are in motion. So I think you have followed this Atwood machine where the acceleration of the system and tension in the string we have calculated when this pulley system is at rest. Now let us see a case 2 where again we will take an Atwood machine and acceleration of the system and tension we will study this time when the pulley moves with an acceleration a0. So let us consider this is the rigid support. Now we have a pulley system and two masses are attached. One mass I'll call as M1. This mass let us say as M2. Now this pulley is moving either up or down. Acceleration due to gravity vector is downward. This in turn mean to say that the complete system, this complete system is moving with an acceleration either up or down, acceleration A0. Let us consider acceleration is A0 in the upward direction. Now for such type of bodies, how we will write the free body diagram and what will be the acceleration and the tension. The one force on this M1 is downward. Let us call this as M1G, tension T. On this body, same string, same tension. Here it is M2G. This body is coming down with acceleration A. This body moving up with acceleration A. Since in extensible string, acceleration of both the masses is same. So, the equation with respect to the acceleration, the pulley system, since it is moving with an acceleration A0, we can consider the acceleration of this body, the net resultant acceleration which we have studied earlier as A equal to M1 minus M2 divided by M1 plus M2 into G. Now we can write this in terms of vector notation as G plus A0, G vector plus A0 vector, and tension in the string as 2 M1 M2 divided by M1 plus M2 into, this will be in terms of vector G vector plus A0 vector. For example, if we take it, the pulley system is moving up. If the pulley system moves up with acceleration A0, then the acceleration will be written as acceleration of each mass M1 minus M2 by M1 plus M2 into G vector. G vector, now I will write it in terms of magnitude. Since it is moving up, it is G plus A0. And if the pulley system is moving down with acceleration A0, then the acceleration of each body will be M1 minus M2 by M1 plus M2 to G minus A0. Similarly, we can also write the tensions. Now you will say how we got these equations. Let us consider the system is moving, the complete pulley system is moving upward acceleration. So this M1 also, although it is coming down inside this system, but net this M1 will be moving with an acceleration A0 upward, as well as M2 also will be moving with an acceleration A0. So the acceleration of mass M1 will be, let us consider as A1, which is equal to A0 minus A. M2 is also moving in the same direction with the same acceleration A0. So therefore this acceleration of M2 will be A2 is equal to A0 plus A. A0 plus A. Fine. These are the individual accelerations of mass M1 and M2 at any instant of time. So if I write free body equations using this acceleration A1, A2 for mass M1, it will be T minus M1G is equal to M1 into A1, or I can write M1 into A0 minus A. T minus M2G for the second body is equal to M2 into A2, or M2 into A0 plus A. Let us expand. First equation, we will take this as equation 1, this is equation 2. From first equation, we get T minus M1G is equal to M1 A0 minus M1 A. Second equation, T minus M2G is equal to M2 A0 minus M2 A. Now we require to eliminate T. Cancel minus plus plus. Subtract. We get it. Minus M1 plus M2 G is equal to m1 minus m2 into a naught minus, or we'll take it minus m1 minus m2 into a. So what will be a equal to? This we can write as minus sign here, m1 minus m2. I'll bring this term here and this term this side. A is equal to m1 minus m2 divided by m1 plus m2 into, this is a plus a naught, this plus, so here we get plus, into g plus a naught. When the system is moving up, g plus a naught, that's what we got. When system is moving down, we'll get g minus a naught. Similarly, tension can be written as 2m1 m2 divided by m1 plus m2 into g plus a naught when the body is moving up, and g minus a naught or the pulley is moving down. So in the Atwood machine is practically a machine with two masses m1 and m2 and a pulley system. If the pulley system is at rest, it's very easy, just draw two free body diagrams, calculate the acceleration. When the pulley system is moving, then we can take the net acceleration as a1 is equal to a naught minus a, a2 is equal to a naught plus a. If imagine the acceleration is in the downward direction, then in that condition what we'll do, this direction is the direction in which m1 will move as well as m2 will move, because the pulley takes both the masses together. So what will be acceleration a1 here? a1 here will be a naught plus a. a1 will be in that case a naught plus a, and this is a1. Similarly, what will be a2 acceleration here? a naught minus a. a2 acceleration can be written as a naught minus a. Followed? Now we are taking these two, a1 and a2, as the reference. Let us make free body diagram and write the equation again. This direction taken positive, we can write this equation as m1g minus t is equal to m1 into a naught plus a. m2g minus t is equal to m2 into a2, a naught minus a. Solving again, we will get these equations. Let us take motion of two bodies connected by a string, with one body on horizontal smooth surface and another body vertically. Also calculate the tension. Here there is a visual which is showing the mass mg going down. This is mass mg, small mg going, because gravity is pulling it down. Tension in the string as shown away from the body. Here we have a horizontal surface capital Mg at the floor, or you can say table. Normal reaction here. The acceleration is a. This acceleration and this acceleration same, because inextensible string. Okay, table applies a normal reaction upward. The block, it balances downward, Wmg. Another block, small m, tries to bring it down, and due to the string strain to produce tension, pulls the block m down upward. Same tension is applied on block m to the right, and this block capital M starts moving on the frictionless table along tension. Another block small m moves down. Let us analyze and write the equation taking the direction of motion as positive. So now I'll just analyze, working out the equations. Picture what you have seen just now. We have two bodies. One body is on the horizontal surface, another body is on the vertical. So let us consider this body is capital M. Another body we have here as small m. Now this is a smooth surface. Let us see what are the forces that are acting on these two bodies. One force is mg, another is tension T, here tension T, this is capital Mg, which is balanced by normal reaction N. This is coming down with acceleration A. Since inextensible string, this is acceleration A. Now let us write the equations based on the free body diagram. Mg minus T is equal to Ma. I have taken Mg direction as positive since it is the direction of acceleration. Equation 1. Second equation. Only one force is there along horizontal direction, that is T. T is equal to capital MA. This is equation 2. Solving. Small mg is equal to capital M plus small m into A. So what is the acceleration? Mg divided by capital M plus small m. And if we require the tension, substitute this value of acceleration in equation either 2 or equation 1. So if I substitute into capital M into A, mg divided by capital M plus small m, or tension T will be capital M small m g divided by capital M plus small m. So this will be the tension in the string, and this will be the acceleration. Followed, we have M due to gravity pulled down, string tension up. This string tension, single string, so tension will be same. T here. Gravity acts, force mg acts on the table, which is balanced by normal reaction. So tension only has to pull it and provide acceleration. This acceleration is same because inextensible massless string. So if it goes 1 centimeter down, this body has to move 1 centimeter here. That's what you will see in this picture. If it goes down, this body has to move in this direction. Let us see the movement of both the bodies again. Due to this weight, the body is coming down. And here T is the cause, tension is the cause for the body to pull it horizontally.